Welcome guys to my channel. This is Chemistry with Min. Today,
What is the ideal fuel? Must have high caloric value, must have moderate ignition temperature, must have low moisture content, must be low non-combustible matter, it must be easy to transport, it must be low cost and affordable, the product of combustion must not be harmful, moderate velocity of combustion, combustion must be controllable, there must be no spontaneous combustion, low storage costs, burn in air with efficiency. There are three types of fuel: solid fuel, liquid fuel, and gaseous fuel. Example of a solid fuel is a coal, wood, and charcoal. Example for liquid fuel is petrol, diesel, and gasoline. And lastly, example of gaseous fuel is natural gas, propane, and methane. Advantage and disadvantage of solid fuels. Some advantage of solid fuels are they are easy to transport, they are convenient without the risk of spontaneous explosion, their cost production is very low, they possess moderate ignition temperature. However, the disadvantage with solid fuel is that their ashes content is high. Um, the large portion of heat is being wasted. They burn proportionally of heat is wasted. They burn with clinker formation. Their combustion operation cannot be controlled easily. Their cost of handling is very high. The advantage and disadvantage of liquid fuel. The advantage of liquid fuel is that they possess higher caloric value per unit mass than solid. They burn without dust, ash, and clinkers. They are easy to transport through pipes. They can be stored indefinitely without any loss. While the disadvantage of a liquid fuel is that the cost of liquid fuel is relatively higher compared to solid fuel. It is costly, especially the special storage tanks that are required for storing liquid fuels. There is 5 times greater hazard, particularly in case of highly flammable fuel, and it gives a bad odor smell. Finally, the advantage and disadvantage of gas fuel. The advantage is that they are clean to use. They do not require any special burner. They burn without any soot or smoke and ash. They are free from impurities found in solid and liquid. However, the disadvantage is that they need a very large container to be stored, and they are highly inflammable, so the chances of fire hazard is very high. What is the difference between natural fuel and artificial fuel? Natural fuel is found in nature. Meanwhile, artificial fuels are prepared by man. So fuels which are prepared artificially are called primary fuels, and these fuels are derived from natural occurring fuels by further chemical processing, so that these are called secondary fuels. So all you need to remember, natural fuels can be found in nature, and artificial is processed by man. So example of natural fuel are wood, coal, and petroleum. And the artificial fuel are some of the examples are petrol, kerosene oil, and coal gas. Caloric value is defined as the amount of heat liberated when unit of mass of fuel is burned completely. It is the amount of heat produced when 1 gram of fuel is burned. When 1 gram of methane undergoes a complete combustion, it's 15,000 kilojoules over gram. So, as you can see at the right side, you can see the different caloric value of different fuels. Caloric value versus low caloric value. Lower caloric value means the total quantity of heat liberated from combustion of unit mass or volume of a given fuel when side products are allowed to escape and the amount of heat released by the vapor is not recovered. So basically, the formula for lower caloric value equals to higher caloric value minus the amount of heat carried by steam. Meanwhile, higher caloric value means the total quantity of heat liberated from the combustion of a unit mass or unit volume of a given fuel when byproducts slash side products are allowed to allowed to cool at room temperature and the amount of heat released by the water vapor is recovered. In this slide, you will see different example of high caloric values of different fuels. Let's solve this equation. All right. We want to find out the high caloric value and the low caloric value of methane. So we have this equation. We need to use, remember the enthalpy equation from our first chapter? We have to use that in order to get the high caloric value. Now that we know what's the product and the reactant, we just need to plug in everything. Okay. In order to get the LCV or the low caloric value, remember the formula HBC. So you just need to subtract H3BC or high caloric value minus to the steam. So in this equation, you can see that we have two steam. As you can see there's two water or steam, and the value for steam is 44. So just subtract it in order to get the low caloric value. The specific energy and specific density of a fuel provides a practical measures of the energy content of the fuel in units more commonly used in the storage and handling of this substance. So specific energy is the energy per unit mass of the fuel, while energy density is energy per unit volume of the fuel. Propane has a density of 0.493 grams. The standard enthalpy of combustion, which is negative 2219 kilojoules over mole, calculate the specific energy and energy density of propane with the molar mass of 44.1 grams over mole. So we want to find the specific energy and energy density. So we are given the heat formula. So we need to use this formula to get the specific energy, which is the enthalpy divided by the molar mass. So the specific energy here, we need to input 2219 divided by 44.1 in order to get the specific energy of propane, which is 50.3 kilojoules. Now, to get the energy density, we need to use this equation. E is equals to energy divided by volume. So the energy is still the enthalpy, which is 2219. However, we know that the formula for density is equal to D is equal to M over B. We just want to get the B, remember? So we need to transpose the equation. So, in order to transpose the equation, we need to use B is equal to molar mass divided by density. So let's plug in all the values. 2219 divided by the molar mass, which is 44.1 divided by 0.493, which is the density, as you can see in the given. Now that we plug and play everything and input that in our calculator, we will get around 24.8 kilojoules for the energy density. How to measure molar heat of combustion of a liquid fuel? First step, a known quantity of water is placed in a glass beaker or can. Second step, a thermometer is positioned with its bulb near the middle of the volume of the water. Step 3. A known quantity of fuel, such as alcohol, is placed in the spirit burner. Step 4. The initial temperature of water is measured and recorded. Step 5. The wick of the spirit burner is it burning the fuel and heating the water. Step 6. When the temperature of the water has risen an appreciable amount, the spirit burner is extinguished and the maximum temperature reached is recorded as the final temperature. The final quantity of the fuel is measured and recorded. Using the data below, calculate the heat combustion of methanol. So, we're given with the initial temperature of water, which is 20 Celsius, final temperature, 30 Celsius. In order to get the temperature of water, so final temperature minus initial temperature. And then we have the mass of water, which is 100 grams. Initial mass of methanol is 20 grams. Final mass of methanol is 19.79. And then you need to subtract the final mass of methanol and initial mass. And the fuel consumed is 0.21 grams. All right. Now that we have everything, let's calculate it. So, first step, you need to get the mole of the fuel consumed. So, we know the molar mass of methanol is 32 grams. And then, all you need to do is divide the fuel consumed and the molar mass. So, it's basically 0.21 divided by 32 moles. Now that we got that, let's calculate the enthalpy increase of water using, remember the equation MCAT. Q is for heat, M is for mass of water, which is 100 grams, C is for the specific heat, which is 4.18, and then change in temperature, which is 10. All you need to do is just plug and play and multiply everything. Now that we have that, the answer is 4.18 kilojoules. All right. All we need to do to get the heat of combustion, we need to divide the enthalpy increase of water over the mole of the fuel consumed. Once you got that, you will get the heat of combustion of methanol.